Hello all, welcome to the subject of VLSI Design and Technology. This is Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai and Mujhe College of Engineering, Bagoli, Pune. So today in this lecture, we are going to see how to write VHDL code for 4x1 marks using data flow description or data flow modeling. So let's begin. Here we are using one predefined word statement while writing the code. This example shows the implementation of same multiplexer 4:1, and instead using logical operator when statement is used here, and also when and select bar when and else statement we are going to use, and other one is with select and when also. We will try to complete that one also. So let's begin with the when statement. Here I have declared the library. Here I have already declared the library and start with the entity. The entity name is mux and start declaring the ports. See, there are 4 input terminals A, B, C, D in the figure. See, there are 4:1 mux means we will get single output according to the select bit. Using select bit, we will choose which input will be a output terminal. Here A, B, C, D, 4:1 is nothing but 4 input terminal here and 1 output terminal, and 2 select bits are there. If the select bit is 0, 0, the input A will going to connect at the output, and whatever the input is there, that will available at the output, which simply provide the path, which simply connect the path where we want. If select pin is 0, 1, then this pin will be connected. If select bit is 1, 0, terminal C will be connected at the output, and 1, 1 is nothing but this will be connected at the output. So this is the performance of the 4:1 mux. We have to write same function by using VHDL code. Here in the port we have mentioned A, B, C, D is in STD logic function we have mentioned here, and similarly we have to write other input terminals. Those are select. Instead writing S0, S1, I am taking a vector data type here, and those are in STD underscore logic underscore vector. This is vector data type. I am taking here 1 down to 0. Then Y is the output here. We have to mention it out, and data type is STD underscore logic. Then we have to end the entity using predefined word and with the name of the entity, that is we have mentioned mux. Then let's start with the architecture part. Architecture mux of. This is the name of the architecture. I have given same name here. I will change this mux 1 of the entity mux. Is a predefined word. Then we have to start constructing architecture by using begin command. After begin, we have to assign how the output is assigning here. The output is assigning by using this assignment operation, this one, and we have to write at y output. I want a input terminal. I want to connect a input terminal when this is the when my bit select bit is equal to 0, 0. See here, I have mentioned that when these two bits are 0, 0, then at the terminal of y, the A input terminal should be connected to Y output terminal. Whatever the output available, that is passed through the input terminal A. If this condition is not happening, then what will do? We have to write else. If that condition is not satisfied, this condition is not satisfied. When select bit is not 0, 0, then what will do? Then we have to pass, or we want to pass B when our select bit that is equal to what? 0, 1. If select bit is not 0, 0, then what will happen? If select bit is not 0, 0, else, then we should pass B when select bit is 0, 1. The select bit is 0, 1 is nothing but the B will be connected to the output. If this condition is also not satisfied, then what we'll do? We have to write else. This one is not satisfied. We have to connect input terminal B at the output when there is another one condition. Then what should happen? Then the select bit should be like 1, 0. If that one is not also not satisfied, if this condition is not satisfied, if 0, 0, A should be passed. If 0, 1, B should be passed. Not if those conditions not satisfied, then 1, 0 is there, then C should be passed. When select bit are not satisfied these conditions, if select bit is not equal to this bit, if the select bit is 1, 1, there is only 4 combination. There is 4 combination 0, 0, 0, 1. There is only 4 combination 0, 0, 0, 1, 1, 0. What is except else combination? That is 1, 1. So we don't need to write. We can simply write else D. What will happen here? If select bit is 0, 0, then A will be connected to the output. If select bit is 0, 1, then B will be connected to the output. If the C, if select bit is 1, 0, then C will be connected to the output. If all those conditions not satisfied, only one condition is there which should be satisfied, that is 1, 1, because there is only 4 combination. So that's why if these condition not satisfied, simply it will connect D input terminal at the output terminal. So this is the simple assignment using when, and we have to end with the architecture by using and mux underscore. What is the name of architecture we have given? Mux. So this is the simple VHDL program for the operation 4:1 mux. Next, see the another one of example. We have to write VHDL code for tri-state buffer. This is the symbol shows the tri-state buffer. Here, the tri-state buffer consists of single input and output. And here we have to consider the example. There are 7 bit, 8-bit input, and output is also 8-bit. So it will send the 8-bit data and also receives the 8-bit data at the output. We can get 8-bit data at the output, but The tri-state buffer is simply just add some amount of delay, and it will provide output whenever only the enable is active there. Here see the enable is a active low, hence the buffer allow only the data from the input to output when the low enable pin. When the low signal on the enable pin, then only the output, only we will get the output. So let's write the VHDL programming. Here we have already mentioned the library, and we have considered the name entity as t underscore buff. This should be t underscore buff. The name of the entity is t underscore buff. Let's start assigning the code. There are only three terminals there. First terminal is input. We can assign the name input also. Input underscore, which is in a form of in std underscore logic underscore vector. This is also in the form of vector. There are 8-bit input signals are flowing at the terminals. So how we can say 8-bit? 7 down to 0. And also there are single output terminal, and we can assign as out, and using same std underscore logic underscore vector, that is also 7 down to 0. Sorry. And another pin is E pin or enable pin, is also input type. So we can say in this is only single bit, so we cannot take as a vector data, only single std logic. Okay, so this is end of the architecture. We have to close and then should give the semicolon, and we have to end entity by name of the entity. So end of the name of entity t underscore d. Now let's write program. Let's begin constructing architecture. The name of the architecture is state buffer. State buffer of, for which entity we are going to constructing architecture, for entity t underscore buff is, then begin with a begin command. Then we have to assigning output. So here our output is named as output. We are going to assigning our output should be input. What is our output? Our output should be input when E is equal to 0. This is active low enable pin. The enable pin will be active when low signal is there. If E is not equal, then what we'll do? We have to write else before giving condition. Then we have to give here else. We can flow other. If there is no any output, we can flow. If enable pin is 0, we can flow high impedance also. We can flow high impedance signal also. We can flow. So we can write other. It should be flow. What is that? This is high impedance. Then we have to end with the end command. Name of the architecture is key_buffer. This is the simple example of tri-state buffer. And similarly, we can write the similarly, we can write for same in the same process. We can write VHDL code for any devices. We have seen many program or application writing the code in a VHDL using a data flow model. So in next lecture, we can see the same examples or few more examples by using behavioral model. So this is enough for the day. Thank you.